Hello and welcome to Homework 4. In this homework we will frequently use the relation that the variance of x can be written as the expectation of x in the power of 2 minus the expectation of x, and all of that in the power of 2. We will use this frequently in this homework. Okay, let's do exercise 1 and let x be the random variable associated with a coin flip. In the sense that x is equal 0 if tail and 1 if head. Assume that the probability of head is the probability of x equal 1 is equal p. And then the probability mass function, PMF, is f of x equal the probability of and then the probability mass function f of x equal the probability of x equal x to x is the Bernoulli distribution. Which looks like this. F of x is equal p in the power of x times 1 minus p in the power of 1 minus x, comma for x equals 0 or 1 and 0 otherwise. Okay. And then we can start. This is the information we get from the text, and in A we are asked to show that the expectation of x equal sum x equal 0 to 1 x times f of x is equal p. And this is the expectation of x. So let's show it. We start with what we are going to show, namely the sum x equals 0 to 1 x times f of x. And then we know what f of x is, so we can write this as x equals 0 to 1 x times p in x times 1 minus p in 1 minus x. And then we can fill in, we can write out the sum. So first x equals 0, so then we get 0 times p in 0 times 1 minus p in 1 minus 0. Then I have let x be 0, then we'll go further in the summation and let now x be 1. And then I have to plus 1 times p in 1 times 1 minus p in 1 minus 1. And then we get something multiplied with 0 is 0, so all this is 0. plus 1 times p times 1 minus p in 0, but something in the power of 0 is typically just 1, so here it stands 1 times p times 1, and the answer is 0 plus p, which is p. And that's what we was asked to show. Then we can do b. Here we are going to show that the expectation for x minus p in the power of 2 equal the sum x equals 0 to 1, x minus p in the power of 2 times f of x is equal p times 1 minus p. So this is what we are going to show. But this is nothing else but the variance of x. As this was the expectation of x. But we know that if we are, we know that the variation, we know that this can be written as this, since it is the variation of x. And so instead of using x minus p in the power 2, I will use this other relation. So I start with the expectation of x in the power of 2 minus or let me write like this. Let me write var x equal the expectation of x in the power of 2 minus, and we know what the expectation of x is, because that we have just calculated here, that's p, so it's minus p in the power of 2. So then we just have to understand what this expectation of x in the power of 2 is, and that we have to compute on the side here, so I do that here. So the expectation of x in the power of 2, that is equals sum x equals 0 to 1, x in the power of 2 times f of x. And then I write this as, I fill in for f of x, and f of x we know that is p in the power of x times 1 minus p in the power of 1 minus x. And then we can write out the sum. So first x is 0, x in the power of 2. So first x is 0, so then we get 0 in the power of 2 times p in 0 times 1 minus p in 1 minus 0 plus, and then x is 1, so then we get 1 in the power of 2 times p in 1 times 1 minus p in 1 minus 1. And this is 0, because something multiplied with 0 is 0. And plus 1 times p times 1 minus p in 0. This gives 0 plus 1 times p times and something in 0 is 1. So this is just p. And then we got that the variance of x is, now we can fill in for the expectation of x in the power of 2, which is p, minus p in the power of 2, which is the same as if we factorize p outside the parenthesis, we get p parenthesis 1 minus p, like this. So there we have shown what we was asked to show. Okay. Then we can do C. And here we let g of x be equal to x minus 1. And let p equal 1/2. Fair coin, if you can say it like that. And we are asked to show, we're going to show two things, but let's take one at a time. So first we're asked to show that the expectation of g of x is equal to 0. Okay? Then we have to start with the expectation of g of x, which is equal to the sum x equals 0 to 1, g of x times f of x. And then I can put in the replace g of x and f of x with their respectively expressions, like this. And now we have to take in account that f of x, which normally was p in x times 1 minus p in 1 minus x, with p equal 1/2, we get that f of x, is equal, instead of p, we write 1/2 in x times 1 minus p, 1/2 in 1 minus x. And this is nothing else but 1/2 in x times 1 minus 1/2 is 1/2 in 1 minus x. And since we have the same base here, we can write this as 1/2 in x plus 1 minus x. And this is nothing else but 1/2 in 1, which is 1/2. So f of x is actually just equal 0.5. And g of x, and that's because either x is 0, then and that's have a probability of 1/2, and or x is 1, and that has also a probability of 1/2. So it has to be a constant. And g of x is still 2x minus 1 times fx equal 1/2. And then we can do this in many ways, but let's do it like this. Let's multiply 1/2 inside the parenthesis, and we get 2x times 1/2 is just x minus 1/2. And then we can write out the sum, and we get 0 minus 1/2 plus, and then x is 1, 1 minus 1/2. And we get minus 1/2 plus 1/2 is equal 0. And that was what we was asked to show. And then we can do the last task in exercise 1, which is show that the expectation of g of x in the power of 2 is equal 1. Okay. Remember, f of x is 1/2 still. So this we are going to do, and then we just write out this expectation. this is nothing else but the sum, x equals 0 to 1, and g of x in the power of 2 is 2x minus 1 in the power of 2 times half. And this is actually so easy to deal with that easy, somebody maybe don't think it's easy, but we don't have to do very much here. We can just write out the sum directly. So this will be 2, let x be 0 first, so we get 2 times 0 minus 1 in the power of 2 times half. Then x have been 0. Now x is 1 plus 2 times 1 minus 1 in the power of 2 times half. And this is 0 minus 1. That is, okay, we take it easy, like this. Plus 1 in the power of 2 times half, because 2 minus 1 is 1. And then we get minus 1 in the power of 2, that is 1. So this is 1 times half plus 1 times half, which is half plus half, which is 1. And that was what we was supposed to show. So, okay, that was exercise 1. Now I'm going to make a little shorter videos than before, because I think that's more effective. And you can just play it back and forth as you want. So this was the first video. Okay, bye.